Hi, now we're going to go through the answers to lesson 3. First question, what speed will a ball be at when it falls through 10 metres? A couple of you are confused, didn't put down the mass of the ball, but as we'll see that really doesn't matter. The answer is independent of mass, and getting used to having things just as an M and not as a number is good. Keeps your brain working. So, we need to solve this as both a kettle and as a roller coaster and make sure our answers are the same. Kettle, energy solution first. We know it has a certain amount of gravitational potential energy at the top. The trick we're going to use is we're going to assume all of that has turned into kinetic energy by the bottom. Of course, we're assuming here there's no air resistance, but we are physicists, we're not engineers, so we will be doing that a lot. So, let's have a look. We know our gravitational potential energy is going to be equal to the change in height times the mass times the gravitational field strength. Change in height, it's falling 10 metres, that's easy. 10, mass we don't know, so we'll leave that as an M. Gravitational field strength, we're on Earth, so it's 9.8. That gives us 98 M. Kinetic energy, we should all know the kinetic energy equation by now. That's just half times mass times velocity squared. So we can put those equal to each other because we're assuming all of this is turning into this. So 98m is half times m times velocity squared. M's cancel, take the half over. 196 equals v squared. So v is going to equal root 196. Simple. Now we think about the force solution. Go back to forces, F equals ma. We should be thinking about acceleration. Think about acceleration, suvat. That's where your brain should be going. Whenever we're doing suvat, we need to just know 3 of them. Do we know 3 of them? Let's have a look. We know the distance it's going to move through is 10. We know the initial speed is going to be 0. We know that we want to find out the final velocity, and we know the acceleration is 9.8 because we know that the acceleration of everything falling is 9.8 regardless of mass. Remember, light things and heavy things fall at the same speed. We don't know the time, but that's fine because we now know 3 things and we're trying to find one of them. So which equation are we going to use? We need the one that has S, U, V and A in it. Take a moment, can you remember that off the top of your head? It is V squared equals U squared plus 2AS. We know U is 0, so V squared is just going to equal 2AS. Whack in the numbers, V squared is going to equal 196, so V is just going to equal root 196, and we have shown that they are equal to each other. Easy. Other 2 equations, rockets. How does a rocket work? End of the day, all a rocket is a momentum transfer. You chuck stuff out the back, you move forward. So if you just remember that basically every rocket question you ever do is probably going to be a force solution because it's going to be based around momentum, you'll be fine. Occasionally they might do a question about how much kinetic energy is it gained, or if we burn this much energy, what speed will it attain, but you can normally spot them. But in general, whenever you see rockets, immediately go to forces because that's what a rocket is, it's just a momentum transfer. Chuck fuel out the back, you go forward. Simple as that. Finally, what's the equation that links the 2 kettles and roller coasters? Anyone get it? Work done is force times distance. Simple as that. Whenever you're moving a force through a distance, you're doing work. And remember, work is energy. The only thing to be careful about that one is it's distance in direction of the force. It's a tricky one. It can be a little bit fiddly. There's a bonus question about that in the bottom for the people who really want to go further. Otherwise, I'll see you tomorrow.